Hi everyone, in this video I'm going to talk about base rate fallacy for any disease like COVID-19. Have you ever heard that a person tested positive but that person was not really infected? Would you believe me if I tell you, even if your test results are positive, the likelihood of you being infected still depends upon the number of infected person in your city. Now, you might be wondering, how is that possible? Well, let's see together. One of the popular tests for COVID-19 uses antibodies. Let's assume it has accuracy of 95%, which means the remaining 5% of time, this test gives us false positive. That is, your test turns out positive, but you don't really have COVID-19. Let's have a look at an example, and let's assume that there is another test which has 99% accuracy, which is closer to ideal. Let's also assume that in your city, out of every 10,000 person, only one person is truly infected. Now, you feel COVID-19 symptoms and you go to a testing center and your test results are positive. So, what is the probability that you actually have COVID-19? Many of you might say that it's option A, which is 0.99, as the accuracy of test is 99%. But you'll be surprised that the correct answer is option D. Let's see how. To understand this, let's first learn about the Bayes theorem. Bayes theorem says probability of event A given B equals probability of A times probability of B given A divided by probability of B. Here, A is the event that you have a disease and B is the event that you tested positive. Probability of A is also known as prior probability, that gives the information from the past. In this case, probability of A is the probability of you having a true infection, which is 1 in every 10,000 in our example. Probability of B given A is the accuracy of the test, which is 0.99. Probability of B can be calculated by combining the probabilities of being infected and not being infected. In the second part here, probability of B given not A is the probability of testing positive but not being infected. And probability of not A is the probability of you not being infected. After injecting numbers, the probability of being infected given your test results are positive equals 0.01, which means there is only 1% chance that you are infected after testing positive, even though the accuracy of test is 99%. So we learned that the likelihood of you being infected if your test result is positive has a huge dependence on the infection level of your city. These calculations, however, assume that the infection is randomly distributed throughout the city, and this math will not apply to the individuals traveling from different parts of the world in the quarantine facilities. This is because the probability of A is different for each individual. So you see how maths is applicable in our everyday life. Hope you guys had fun watching this video. Thank you for listening.